Thank you, Tom. Yeah, so I'm Robert Masolele from Wageningen University. So I'm so happy to introduce this topic on mapping land use following deforestation across the Pan-Tropics with Sentinel data. Of course, this work is in collaboration with many partners, co-authors who are involved in this work. So the main point in this talk, of course, is mapping land use following deforestation. And I would like just to start first by introducing what we mean by land use following deforestation. Okay, so what is land use following deforestation? So this is the key point for this presentation. So just imagine you have a forest somewhere, right? There is a very dense forest, and so humans happens, right? And they do their thing. So basically, you expect when human activities take place, these forests changes. So changes happen to that forest. And of course, if you are close by or nearby, you can easily detect, right? You can go there and try to understand what is taking place around that. So you can really identify those changes. But also with satellite, of course, just visually, if you see that there is a change. So here there is greenness and there is a change. So basically the forests are being converted. However, the challenge is understanding really what caused these changes. So I mean, there is a change, but a change from what? Or we can say, okay, maybe it's agriculture. Generally, it can be easier to identify, but what kind of agriculture, or if there is some changes, maybe it's mining. So it's really challenging to understand what kind of change is happening. So visually, you can easily identify. So if you are close to the area, you can go identify. So we in this work we just try to use computers. So instead of visually identifying what is taking place here, we use computer algorithm to try to tell us what kind of change is happening. And for example, for this case, here we identify, okay, here there was soil which was established after deforestation. So basically that's what it means. So we try to understand, okay, there was a forest and there is some activities which are taking place, and then we try to identify what kind of activities are taking place after deforestation. So basically that's it. That's the basis for the entire presentation. And in short, there is a forest, there is human activities, we use computers to identify what kind of changes are happening. However, so as I said, you can easily identify by physically identifying, going through satellite images or going to the field, but it's so complex because forest changes are happening every year. So globally, every year, that can be a very daunting task. So that's why the use of computer algorithm can really help to try to scale this to global or even country level, or at least here we are talking about the Pan-Tropics. And so the essence is to understand what's happening after deforestation and the specific what kind of land use is causing this. And this work, of course, started with, of course, part of my PhD. So basically, we tried to identify different algorithms which can really help to try to identify what kind of land use that's causing deforestation. And we did that across different scales, across regions, so like countries, continents. And also we had some really case studies at country level. So with partners, for example, this work was done in Ethiopia with partners from Ethiopia. And so we had like different testing, so different data, so like Planet, very high resolution, Sentinel, Landsat, and of course the Ensemble. So there's a lot of ablation study which was done on this, trying to come up with the best method, best approach to try to identify the land use that's causing deforestation. And we also upscale this to continental scale. So for example, this study basically for Africa, using an active learning framework. And where you can see really with active learning, we're able to increase the accuracy of identifying. If you see, for example, in this chart, you can see really after every training iteration, we're able to gain some kind of accuracy in detecting the land use. So we mapped this across the entire continent for 15 classes. There is this app you can really go and see via this link. And I just want to here mention one thing about the usefulness of this data. It's not only about mapping, right? And just seeing what is kind of changes. So because we are mapping over time, so you can really see the changes, the interaction between different land uses. So for example, in this case, this was in Eastern DRC, we try to identify, so you have like mining, and most of the reports, they tell, okay, you have a lot of small scale agriculture which is taking place. But then with this interaction, you can try to understand the complexity of what is happening. And what you identify is that normally, because of the situation which is happening along those areas, although you can not see a lot of mining because mining establishment are just pits, in terms of area, they cannot contribute. But generally, agriculture follows mining because people are moving, like shifting, and then whenever there is a mining activity, you see people also moving there, and then agriculture coming there, which is really impressive. And that shows the usefulness of this data, that it does not only stop at when you have a map of land use, you can use that to really check the impact of these kind of changes and why they are happening. So we currently upscaling this to Pan-Tropical, and this the talk for today, and also adding more classes to 23 classes. And of course, this is also linked to the current European deforestation legislation, UDR, which of course it's intended to limit the import of commodity related to deforestation. But we're expanding more into this because it's not only these crops. I think this varies depending on region. In some region, probably there is no even these crops, but the other crops. So we use a database. Of course, it's a very complex database. We have like more data, so around more than 3 million reference data points scattered across the Pan-Tropics, and you can see the kind of diversity even from the training data. Like in different regions, you have different kind of data sets which are dominating in those areas. And of course, for each classes, we try to identify, to define what we mean by, if we say, for example, if it's cocoa or for example, it's mining, because you can have like different definitions on these classes. We use an active learning process and machine learning. So basically here we have like 3 input of Sentinel 2, Sentinel 1, and allocation information. We use 3 branches of CNN network, which are fused at the later end of the network to be able to predict different land use categories. And of course, the importance of this separation, instead of just combining all the data into one, is that we try to make sure that each data is really full contribute to the output. And that helps really in trying to understand the complexity of these different land uses. Just to here to show why, of course, for example, one of the important, like for example, location is important because as you can see from this graph, you can see there is a lot of increase in accuracy whenever we had a location compared to if we don't have location, because land use varies depending on region. So that's critical important here. And why it is important to have location information in our model. So based on that, we are able to predict, use this model to predict across the Pan-Tropics, and we assessed accuracy. So this is an activity which is still continuing. So this is not like the final. So currently for assessment, we're still, of course, improving this and adding more data. We have like an accuracy of around 88%. And just to zoom in, so our results, you can see, for example, the main drivers of deforestation. So the land users follows after deforestation. Here you can see, for example, in Latin America, it's mostly soy and pasture. And of course, you can see some patches for cocoa and coffee, but mainly dominant, you can see soy and pasture. This is a different picture when you go to Africa. So you get even more complex. So you can see you have in the West Africa, you have more cocoa and cashew. And like in Central Africa, of course, going to Southern and East Africa, a lot of other small scale agriculture. And some patches, like for example, coffee in like Uganda, all the way to Ethiopia, and they also have a lot of maize along the southern and Eastern Africa. So that's kind of give you like a complexity, like especially in Africa, of what is taking place. And that's also different if you go to like in Southeast Asia, where you have oil palm. Um, Dominant is at least especially in Indonesia, and you also, but also for example in uh, Sumatra, you have kind of pattern with a mix of coffee and cocoa. And if you go, for example, in zoom in, for example, in Vietnam, you can get a different picture. Here you can see coffee, mostly like in Vietnam, and also cashew in Cambodia, for example, and also rubber, like go all the way to Thailand. Uh, we also view, for example, in Suriname, the complexity here, it's more not like a commodity, but you can see mining and logging activities, which are really impacting this forest structure, the Amazon infrastructure in Suriname. So, and this is very useful because it can give you, like, for example, there are so many activities taking place, of course, including small scale agriculture, but also the river systems, so hydrological cycle here, because I think mining here, you have a lot of activities, maybe chemical, which are used to process, retrieve the mining, but also logging. This like data can be really useful for further studies of what impact in forest, but also to humans, because of course we talk about forests, but there is also impact which happen human because of these changes which are taking place. Another, we normally talk about, for example, Ghana and Ivory Coast, mostly the impact of cocoa, but there is also impact of mining. So especially you can see in recent years, there is a lot of this artisanal mining which have been taking place in Ghana. So you can really see, for example, this small part of forest. So just 1 year in 2023, the entire like forest patch was gone. So you can select from this slide. So that's give you how mining can really impact. So just within a year, with 1 year, the entire forest, this patch has gone to small scale mining. And this is not only impacted forests, meaning that some of also the crops of cocoa farms are being converted because probably mining has a higher economic impact to people than cocoa. So the interaction of all these land use changes, it kind of create a very complex picture of what happens next. And of course, the impact which it creates to the community along these places. Similarly, if you go like to Costa Rica here, we see like most of dominated by coffee expansions. And Honduras, for example, you can see the pattern mostly on coffee moving along the mountains, so these mountains regions. So what the future will look like maybe in 10 or 15 years. Similarly, for example, here in Ethiopia, you can see this is a different pattern. So mostly kind of most agroforestry, you have trees and you have coffee underneath, and you can really zoom in with high resolution, and you can see what is down there. Those are kind of coffee plantation, and you have trees. But if you just look at the image, probably the causal resolution image, you won't be able to see. You just assume it's a forest. So having this data really, it helps to try to understand the context. But also another, for example, expansion. So normally you have these existing plantations, and it can happen that there is an expansion. So with here we try, of course, you detect that although there was a plantation here, maybe it's already supplying its product, But what happens if a plantation expand? Like okay, maybe after 2020, do you really consider it, especially for UDR, as not accessible to the market? And how do you divide that? If it's one plantation, one part is after 2020, one is before. How do you divide? Okay, your product should not be admitted to the EU. So that's also one of the complexity which probably is facing the UDR. Uh, so here I show, for example, the complexity in Cote d'Ivoire, where you have in one place. So not only one commodity, you have multiple commodities. So for example, you can see you have oil palm, we have cocoa, but also we have rubber plantations, just in one location. So just going further to finalize here, one of the point I just want to raise here. So this was like a deforestation happening in Ecuador, but if you see in the forest product, they are not so much detected because the dry forests, like the performance of detection is not so good, so they are missed out. But it only detects some like small, as you can see, pixels. That's why it's important to also improve on that aspect. In the society, we'll be missing a lot of impact of deforestation which is taking place in dry forests of different regions. And this, of course, you can really see what's happening. And these are really like, because they are not small scale, they are really large scale. Cocoa, for example, here taking place along these regions. So just to conclude, we observe that there is a very big regional variation. So when you go from one region to the other, there are different land use that cause deforestation, but also at country scale. And also there is an expansion of different footprints. So you can see commodities not only on UDR. So we saw like there is, for example, cashew, especially in dry forests, but also maize, which is expanding so fast in other regions like Africa. And also the need for continued updates. So this is useful. If it's only one time, probably doesn't make so sense to have it. So this kind of work need to be something which is continuous, maybe annually or every 2 years, to have a very impact to and be able to really understand the changes, and also to assess more of the impact, not only deforestation, but other associated impact which are taking place. So that makes the end of my presentation. Thank you. Gracias and bedankt.
We have some time for questions. Audience. Yes, Greg, and here, 2 questions.
Thanks, Robert, for the nice talk. And maybe this question is maybe the one I asked to Johannes, maybe this is more for you, actually, to a point. I was wondering a bit, I mean, you show these detections, maps and things, but often it doesn't seem like you're catching everything on the image. When we see an image, I mean, sometimes I'm surprised to see that the patches that you detect don't seem so much like a patch that you would expect of a plantation, you know, because some part of it is missing, part of it is there. And I imagine this is partly because you're in this world of detecting alerts of where it's going, no, or like detecting flash. But can you move forward also to actually doing more maps that we can trust that all pixels are well classified locally? And what would you need for that to make it? Because I have you see what I mean, no? I mean,
yeah.
Validation based on points that some are right, it's fine, but in the end, it would be good that locally or globally, like Gilberto says sometimes, no, that everywhere we could be right locally, and so that the plots are well delineated and things like that. And I wonder how you evaluate that, and how can you move forward in that direction?
Yeah. Thank you, Gogol. I think that's a right question. So this is basically based on the deforestation product. So so we use that deforestation product where those detected, and then we do inference based on that. So, and normally, so for example, if you see on these like large farm or on areas where there is very small changes, happening. So you can have like an existing farm, for example. So we don't like kind of detect the entire farm. We only detect the pixel where there is changes. But indeed, so for if you want to detect the entire thing, that's a word-to-word prediction. So you have to predict the entire thing, right? But that's something different. So you kind of want to do a word-to-word prediction, or you are predicting the entire pixel. But this is more focused on like changes. So only where there was deforestation. And of course, there is still some issues because like some of the deforestation, probably they are not from natural forests. Sometimes you find say management practice. For example, if you see, for example, in coffee regions, where you have like a management where coffee is being maybe replaced, and then it detected deforestation, but it was not like a forest initially. It was still like some kind of coffee or another crop, but then it's detected. But yesterday I had a presentation on cocoa where we are trying to map the entire crop. So that's a word-to-word, where like really you can really identify the boundaries of the farm easily. But this it's mostly related to where there is changes happening.
Okay, we have one more question here.
Yeah, so my question actually links to that also, your presentation from yesterday. So basically this was the general model, if I understood it correct. And then yesterday's presentation was fine-tuning that, right? So I think you responded now already a little bit on it, but can you then emphasize which extra data went into the fine-tuned model that we saw yesterday compared to what we see today?
Yeah, so for deforestation, basically you have mostly areas where you have deforestation, right? But then you have old growth, for example, old growth cocoa, right? If you are trying to, for example, for yesterday. So meaning that you also include a lot of data which are not related compared to deforestation. So you like farms, for example, which are they're not areas where you don't have forests, right? But here it's most related. We try, okay, there is forest, there's deforestation, and you try to identify what kind of land use is following. But if you're trying to do a word-to-word prediction, mean that you include all data. It doesn't matter if there is forest or not, because it's just mapping a commodity. So that's the difference.
Just for the end, what do you recommend as the most trustworthy data source, a layer for the deforestation for the world, especially for tropics? What do you recommend as the most trustworthy product or organization?
Yeah.
Or you think this is going to be the most trustworthy?
You mean deforestation or the land use, the data?
So if somebody wants to find out where is deforestation happening, how much, what's the most trustworthy?
Yeah, I think that's it's a mix, because I think especially as a grow product, that's challenging a bit. So as I highlighted, in dry forests, I think there's still a challenge there for almost all the product, because there is a missing of detecting deforestation, but also the challenge of natural forest versus like commodity crops. So there is a lot of mixing, not only one product. I would say like there's still a challenge on every product I can. Yeah.
Okay,
Yeah.
we have to move. Thank you,
Yeah.
Robert. We move to the next speaker, Irene.